everyone, my name is Jenna Campbell, and this is my Lab 1 report on our first virtual lab with the charged tapes. As an introduction to this lab, I'd first like to look at this model to the right, showing that opposite charges attract and like charges repel. And this is essentially what we observed with the tapes. In further detail, what is this lab all about? Well, we learned about net charges on ordinary objects and learned how to test an object's charge and estimate the amount of excess charge it holds more accurately, because even though there's a range that we know this excess charge is in, it's very large, and by using these main physics principles, we're able to find a more accurate estimate. These main physics principles are Coulomb's law and Newton's second and third law. This is shown in this second model here, where I set the gravitational force, the magnitude of the gravitational force, equal to the magnitude of the electrical force when the momentum stops changing of that top floating tape. And we know this because the vertical net force at that moment is 0. And so our experimental results were that I observed that the U-tapes repel each other and the U-tapes were attracted to the pen. And this is further detail on calculating these forces. So for the gravitational force, we had all the information we needed. And then for the electrical force, we just set it equal to the negative of the gravitational force so that their magnitudes would be the same. And this is shown again in this free body diagram, which will be demonstrated better in the VPython at the end of this presentation. For data and observations, my measurements that I found were that the tapes that I cut and used were around 20 centimeters, and their calculated masses were 0.2 grams, or 2 times 10 to the negative 4th kilograms for the calculations, because we needed to get to newtons. And the first U-tape made the other U-tape float at a separation of about 1.3 centimeters. For more qualitative observations, I saw that the U-tapes repelled each other due to having the same charges, and the U-tapes I determined were positively charged because they were attracted to the pen that I made negatively charged by rubbing against my hair. My last observation is simply a complication that I ran into because the tapes were very difficult for me to prepare perfectly for proper results that I knew I should be expecting to see. Going further into that complication on this experimental conclusion slide is that it's really important to handle the charged tapes as little as possible. This is because our skin is a decent conductor, as well as some other objects. So when the U-tapes came in contact with my skin or with other objects, or even due to the humidity in the room, the electrons moved to the surface of the conductor to spread the tape's excess charge more evenly, which is why I had so many issues making the tapes give me my proper results. And for the second provided question for my conclusion, if electrons and protons essentially switched identities, nothing would change. If 2 electrons became 2 protons, they would still repel each other, like shown in the first model on my introduction slide. And the same if they were opposites. They would still attract, even if they just switched identities. Lastly, this is my coding output in VPython. Again, it's more of an accurate depiction, I guess, of the free body diagram that I drew earlier. But the orange arrow is an electric force. The green is the gravitational force. The red is the floating tape, and the blue is just the other piece of U-tape. And so again, this is showing that the vertical net force is equal to 0, and that's how we were able to calculate this Q that I printed down here, along with the 2 forces equaling each other in magnitude. Thank you so much for listening.